bunch of work and a bunch of messiness, and a lot of you guys, probably got stuck on a lot of it. But here's the specific goal of this chapter. If you understand that you can plot a graph in terms of time, like an x and y position in terms of time, that was my goal. That's the goal that I want for you guys. I do a lot of stuff that, some stuff you need for BC, you need to break it down and do all this stuff. But like what I want you to know is that you can do that. Does that make sense? You can put your x position specifically, even though it's a parabola, you can define that x position at time. Okay? Because you're going to take the derivative of that. And then the y position according to time, you can take the derivative of that. Does that make sense, you guys? Okay. So do your best, talk about it, and then we're going to move on. Specific things on it. Does anyone still owe me a syllabus? Anyone owe me a syllabus? 22. Again, you can graph this thing parametrically. You can take a look at it, and it's going to look like a line. So that should tell you that this thing is actually a line. And what you can do is you can solve for t in one of them and dump it into the other one. So if you solve for t in this first one, it's going to equal that. And then you take this whole thing and you jab it into the other one. Then you'll have a new equation with just x's and y's with no t's. Does that make sense? You directly substitute one into the other. So this would equal y equals 2 times x minus 3 over negative 3, which is going to equal negative 2/3. And I don't agree with this. Did someone get plus 2 here? Yeah, I agree with that. So this is negative 2/3 x plus 2. Yeah, I don't agree with that plus 3. So that's taking one, and then you kind of simplify it, but that's it. You know what I'm saying? And in calculus, you guys, I would leave it just like this, without doing any extra simplification. Because on the test, this is correct. This is a line, just in general, get used to that idea. If you do extra work, and you do something wrong, you get it wrong. You lose the point. Does that make sense? So why simplify in a lot of cases if you don't have to? Don't. It takes more time, and you can only lose points by doing so. So those are two bad things. Does that make sense? As soon as you have it, this is fine. Dump it in, you're done. There's your line. It looks beautiful. And then one more problem has to do with if you have sine squared plus cosine squared equals 1. That needs to be memorized. Make sure it's in your brain. Okay? If you divide everything by sine, you get this. 1 plus cotangent squared equals cosecant squared. If you divide everything by cosine, you get this. One of these three things. These are the trig identities that you can use to manipulate equations to clean them up. Like if you have something you see a sine squared plus a cosine squared that's equal to 1, you can take out the sine squared plus cosine squared and make it equal to 1. So that may help you. Does that make sense, you guys? So you can use any one of these. And if you look at a problem like 10, if you get something like, this looks weird, x equals 4 cos t, y equals 2 sine t. You want to somehow, the game is turn it somehow to look something like this, if you want to get rid of the t. If you don't have any sines and cosines, you directly substitute one into the other. If you have something with sines and cosines, you're going to have to use some of this information to get rid of the t's. And here's how you would do it. If I divide this by 4 by both sides and this by 2 to both sides, you would get x over 4 equals cos t, and y over 2 equals sine t. And if I took this thing and this thing and added them together, that should be the same as this thing plus this thing. Does that make sense, you guys? It's like a legal... I just created my own equation out of thin air. But it's a true statement. Would you agree with that, Eleanor? That since these are equal and these are equal, if I add these two together, it's got to be the same as adding those two together. I created my own equation. Okay? Is that a happy or sad shake?
Kind of a sad shake.
Okay. Just in general, if you have two things that are equal, and you take, this is just the same as like, this literally says like 1 plus 5 equals 1 plus 5. That's all it says. You take two things that are equal and just set them equal to each other. And you can square them too. If you take this and square it and this and square it, and this and square it and this and square it, that's still a true statement. Because you're taking something squared and you're just setting it equal to what it's equal to and squaring it. So these things have to be equal. These things have to be equal, and you're just going to add them together on both sides. And why I did that, because now this looks like this. So I can take out the sine squared t plus cosine squared t and just put a 1. And you just got rid of your t's. What's that?
That makes sense now.
It's a game. Yeah, the goal is like, what was the game the whole time? But now that's the game. You want to manipulate this stuff. You can create an equation to get it somehow. If you see cotangent and cosecant, you're going to have to use this one to somehow get rid of it. And they're going to set it up so you could do it. It's just, it's just a silly little game. And moving forward, do I expect you to like have this stuff inside and out? Absolutely not. The goal, expect maybe this on the quiz, but probably mostly just a substituting one tomorrow, just with a line or quadratic or something like that. But moving forward, just have an understanding that you can define a parabola. If something is moving, like a particle is moving, you can calculate its x position and y position separately according to time, and just be fine with that. Does that make sense? Because moving forward, what we're going to do is take the derivative of each to figure out how fast it's changing in the x direction and how fast it's changing in the y direction at specific times. That's what we're going to do. Everything else beyond that is beyond AP. Okay, any questions on any of this? Yes?
So for the second line, technically you can only square it because they're equal, but if there's like something else added on to the cosine square.
Yes, exactly. Yeah, that would be bad. You know what I'm saying? Like, yeah, it looks like I'm sort of breaking rules because you can't just square. Just like you can square both sides or square root both sides. You know what I'm saying? That's something legal to do, right? Does that make sense, you guys?
But you can only square them all at once because they're equal.
Yeah, you can square the entire side, but yeah, since I took one specific thing that's equal, I only know that this is equal to this. Yeah, usually none of this would make sense. You can't just pick and choose things to square. That's illegal. But since these two things are equal, since they're equal, and like if you square the two equal things, then their square is also going to be equal. You know what I'm saying? It's a game. It's just a silly little game. It's Friday night, Mr. R's. We call it chips, dips, and dogs. Okay? You guys, just in general, 1 through 10. Bad? Okay, great. Great. 2s. Great. Excellent. Wonderful. Good news. So what we're going to do is we're going to do some stuff. I'll see you guys after school. I'll see you before school. And we'll work on some. These things do come up a whole bunch. We're just going to look at some specific things today just to kind of work our way through it. This whole section starts out talking about inverses because a log is an inverse of an exponential function. So function is a rule that assigns a single value in its range to each point in its domain. What that means is if you have an x value, you know what the y value is. What that means is it passes vertical line test. An example is x squared.